In this problem, you have to determine the temperature difference between the front and the back surfaces of a chip in the steady state operation. Before going into the detail, let us just try to understand the question statement, which is given here, that the heat is being generated in the circuitry on the surface of a silicon chip which has a thermal conductivity K is equal to 130 watt per meter per second, and this heat is being conducted to the ceramic substance to which it is attached. The chip has the dimension of 6 millimeter into 6 millimeter in size and 0.5 millimeter thickness, and the heat basically dissipates with the rate of 3 watt, which is given in the question statement. Disregarding any heat transfer through 0.5 millimeter high side surfaces, you have to determine the temperature difference between the front and the back surfaces of the chip in the steady operations. Let us just try to understand this question statement with the help of the diagram. So this is a diagram that this is the silicon chip which is placed on top of the ceramic substrate, and the heat is being generated in this silicon chip which has the dimension of 6 millimeter into width, 6 millimeter into height, and 0.5 millimeter into depth. This is the 0.5 millimeter. So the heat generation, which is also given in the question statement, and this has been asked that you have to determine the temperature difference between the surfaces of this silicon chip. This is the one side of the silicon chip, and the other side of the silicon chip is in contact with this ceramic substrate, and you have to determine the temperature difference which is being developed due to this thickness. And in order to determine the temperature difference, so let us just take some assumptions that the steady operating conditions exist and the thermal properties of the chip are constant. So the properties that we need to solve this problem, that is the thermal conductivity of the silicon chip, which is given in the question statement, which is 130 watt per meter per degree centigrade. So the first thing that we have to determine is the area of the chip, and the area of the chip we have to determine the area in meter square units. So we are given with the dimensions in centimeters. We will convert those centimeter units into meter, and after converting the units from centimeter to meters, we will multiply the length into width, and we will get the area, which will be equal to 0.000036 meter square. And the rate of heat transfer through the chip is given by the conduction process, and we have to use this formula, right? And in this formula everything is given. Let me just read it once again. The rate of heat transfer is given, yes, it is 3 watt, and the thermal conductivity is also given, which is 130 watt per meter per degree centigrade, and the area that we have just calculated here, and the thickness of the silicon chip is also given in the question statement. What you have to do is you have to determine this temperature difference. After rearranging this formula, that you will take delta T on one side and remaining all the parameters on the other side, you will get this form of the equation. And after putting all the values and simplifying that, you will get the delta T, which will be equal to 0.32 degree centigrade.